Alright, hello geometry! More trig stuff today, and you may notice I put that this is section 8.4 and 8.5. I should have either gone with 8 dash or 8 dot there and just picked one, but this is a little bit of both sections because 8.4 was a little bit too long to just be one section, so I wanted to split it up, and then 8.5 is pretty much all story problems, and I didn't want to write a whole bunch of story problems out of my little whiteboards, so we're going to lump them together with the second half of 8.4 and then all of 8.5. So you may notice if you're looking at the homework, most of the problems are from this, there are a couple from this, so it's mostly this with a few story problems. I'll do a few story problems at the end. I just didn't want to do like a whole section of story problems because that would be hard to do with these little whiteboards and with you just watching with videos and not really able to ask me questions while I'm doing this. Alright, so that's why it's both sections. So, more trig. And what we're looking at today is last time we were looking at using our sine, our cosine, and our tangent to find sides of our triangles. Now we're going to be using them to find the angles. Okay, but we're still doing the same sort of thing. We're just going to have an extra step at the end. So if I'm looking at this triangle, and I'm looking for my angle x, if I'm looking for this one, your side across from your right angle is always your hypotenuse. That's your freebie. And this side that's touching our angle, so not the side opposite, this one is our adjacent side. Now, technically, if you wanted to use your opposite side for some reason, you could go through and Pythagorean theorem this and find this side, but we're not really looking for this side. We're looking for this angle. And if I've got my adjacent and my hypotenuse, that's going to be my cosine. So your cosine of, this time we don't know what the angle is, so I'm going to call it x. So your cosine of x is going to be your adjacent side, which is 13, over your hypotenuse, which is 17. Okay, but 13 over 17, that's just a decimal. Let me find what that is as a decimal real quick. So 13 over 17 gives you 0.7647-ish. Now, importantly, that's not your angle. That's the cosine of your angle. So in order to get the actual angle, you're going to look for a button on your calculator that looks like this. So you're looking for something with a cosine with a little -1 there. That's the sort of thing you're looking for on your calculator on your phone. Oh, I was just assuming it was there. Okay, yeah. So if you're using the calculator on your phone, you're going to want to hit the shift key and then your button. So shift key is like right below there. So shift and then your cosine. Whoops. I got them both. Okay, so shift and then your cosine. And it should pop up something that says a cosine. Again, if you're using a different calculator, that's fine. That's just where it happens to be on this one. So you're looking for a button on your calculator that either says arc cosine or a cosine or cosine with a little -1. And then you're punching in that decimal that you just got. So 7647. And again, for this, you're going to want to make sure your calculator is in degrees. And it should give you something around 40.1-ish. Now, just a heads up that if you punch in the inverse cosine of your decimal or your inverse cosine of 13 over 7, you will get slightly different things. The more decimals places you put on this, the more accurate that's going to be. But if you just punch in inverse cosine of 13 over 17, you'll get something slightly different. So if I punched in the decimal, I got 40.11. If you punch in the fraction instead, you get 40.119, so technically 40.12. We're talking about 100th of a degree. Close enough. Close enough. So I don't really care if that's 40.11 degrees or 40.12 degrees. It's 40.1 degrees. Close enough. Okay. So then we get about 40.1, and that's in degrees, because we're looking for angles. So anytime you're looking for an angle, that's going to end up in degrees. Okay, let's try another one. And same sort of thing as last time. Really, the big thing here is watching out for, are we using our sine, are we using our cosine, or are we using our tangent? So if we're looking for this angle, this is our opposite side, because it's the one that's not touching it. This one's our adjacent side. So if we have opposite and adjacent, that's the TOA part of our SOHCAHTOA, because we have opposite and adjacent, so that's tangent. So this time we want the tangent of, I'm going to call it x, is our opposite side, which is 11, over your adjacent side, which is 8. 11 over 8 is a nice decimal, so this one will get the same thing either way, which is 1.375. And again, that's not your angle. That's the tangent of your angle. So if you're looking at that going, Miss P, that's too small to be my angle, that's not your angle. That's the tangent of your angle. So you're going to want to hit your shift button to get that tan with a little -1 there. So the inverse tangent of 1.375 is about is about 53.9-ish, 7-ish. That's a 3. And again, that's in degrees. And if we're looking up at our angle, 53.97-ish, that sounds about right. Because we know this side is longer than this side, so this angle's got to be bigger than this one. This one's already 90 degrees, so 53 is bigger than the 36.3 we would get over here. So we're in the right ballpark. Alright, one more. Get smudged a bit. Alright, so let's say we've got 27, 42, and we're looking for this angle. So your longest one's always your hypotenuse, and even if you're not sure it was this longer, is this longer, if it's not quite drawn, to scale-ish, your longest side is always across from your right angle. So that one's always your hypotenuse, and then 29, that's not touching the x, so that's our opposite side. So that's our part of SOHCAHTOA. So we've got the sine of x is going to be our opposite side, which is 29, over our hypotenuse, which is 42. 29 over 42 is about 0.6904-ish, 0.6905. Put that over here. So then that's our sine of x. So then we want the inverse sine. So we want the sine with a little -1 of 0.6905, which gives you about 43.7-ish. Alright. And again, we're in degrees. Okay, now, the second part of what we're doing with this is we're throwing story problems and word problems back in. And this part's going to be a little bit of a mix of what we were doing in the last section and what we were just doing. So sometimes we're going to be looking for the side, sometimes we're going to be looking for the angle. So if I've got this, and a little picture going on, and I've got Miss P standing over here at, let's say, 5 feet because I'm short. And let's say we've got a tree, and we've got a 25-degree angle, and we want to know how tall is the tree. And we're assuming with these sort of story problems that our tree is, standing straight up and is making more or less a right angle with the ground here. Because again, all the stuff we've been talking about, this only works with right triangles. So we're assuming here that this is a fairly straight tree. Okay. So we're looking for this. We've got a triangle here, which again we're assuming is close enough to a right triangle. And we've got 40 feet, because if I'm standing 40 feet away down here, this is going to be 40 feet away up here. And we're assuming this is mostly straight up and down. Alright, so we got 40, and we're looking for this. Now, technically, we're looking for this. We're going to deal with that in a moment. Right now, we're looking for this side of our triangle. So we have our adjacent side, because this is next to our 25 degrees. We're looking for our opposite. So opposite and adjacent is the TOA part of our SOHCAHTOA. So our tangent of 25 degrees is going to be our opposite side, which we're looking for, over our adjacent, which is 40. Tangent to 25 is just a number. So I'm going to take that and then make sure you're out of the inverse tangent thing. So we want the regular tangent this time. Regular tangent of 25 degrees. Which gives about 0.466. And then we're getting rid of dividing by 40 by multiplying by 40. Which gives you about 18.6-ish. 0.7, that would round up. So about 18.7-ish. Now watch out for that's not quite the answer. Because that was this. We want the whole thing. So we're going to add in that 5 extra feet here, which is going to be 5 extra feet over here. So plus that 5 gives you 23.7-ish. That's in feet. Okay. So just watch out for that if there's something you have to add back in after you found the side of your triangle. So if we've got a height here that we're either adding or subtracting to get to our actual thing that we were looking for. So we were looking for the height of the tree, which is this whole thing, not just this. All right. Let's say we got a kite. So we're flying a kite. Let's go fly a kite. Mary Poppins? Okay. Yeah, no. Okay. You probably wouldn't have laughed it anyway, even if you were here. Okay, so again, assuming that we're going at more or less a right angle here, we've got 50 feet going up to this kite, and we want to know how long is the string. So we're looking for this. So we're looking for this, because that's our string going from our person to our kite. Okay, so we've got our adjacent side. We're looking for our hypotenuse. So that's the ka part of our SOHCAHTOA, because we have our adjacent, we want our hypotenuse. So our cosine of 30 degrees is going to be our adjacent, which we have, over our hypotenuse, which we're looking for, and the cosine of 30 is just a number. Length is about 0.866. And again, these ones, watch out for you're not dividing that by 50. We're actually going to take this times x, cancel out those x's, and then we got 0.66 or 0.866x equals 50. So we're going to divide by 0.866. So 50 divided by 0.866 gives you about 57.7-ish. Okay. And again, that seems like a pretty reasonable length for our hypotenuse, because we know we want it to be longer than this, but this is a 30-degree angle, that's a pretty skinny angle, so not too much longer. So 57, that's not in degrees, that's in feet. My bad. So 57 feet, yeah, we're in the right ballpark. Okay, now we all know that the tricky part with story problems is not when you already have a picture, it's when you have a bunch of words instead of a picture, and you have to get your own picture. So we got Tim. My cousin Tim flies planes, he actually does. And he's landing a plane, and he's at 600 feet above the ground, and he has a horizontal distance of 4,000 feet to land, and we want the angle of depression he should land at. So really the big thing here is figuring out what's our picture going to look like. So I got a plane. This peak and drop planes. Whee! That's a terrible plane. That looks like a fish. Okay, so I got a plane that looks like a fish. And wildly not drawn to scale, we know he's 600 feet up in the air. And he's got a horizontal distance of 4,000 feet to land. And if we're looking for our angle of depression, I can draw a little triangle here. But what we're actually looking for is this. So we want to know how far he needs to drop what angle he needs to drop at in order to get to a distance he can safely land at. So we're looking for this. So a couple different things you could do with that. You could find this angle and then subtract it from 90 to get that. You could find this angle and then say because we have parallel lines, it has to be the same as this angle. The other thing you could do is draw your triangle over here. So actually, I'm going to do that. I'm going to redraw this so that my triangle actually looks like this. So this is still 600, this is still 4,000, but now I'm looking for this instead of looking for this and finding that. Alright. So any of those will work. This is probably the simplest way to go about that. So if we're looking at our little plainfish angle here, we've got a opposite side. And again, assuming this is a right angle, we've got our adjacent side. So opposite and adjacent is the TOA part of our SOHCAHTOA. So the tangent of the angle that we're looking for is going to be your opposite over your adjacent. And 600 divided by 4,000 is about 0.15. So this time, if you're looking for the angle, anytime you're looking for the angle instead of a side, you want your inverse. So you want the inverse tangent of that 0.15. And technically what we're doing there is we're taking both sides and we're inverse tangenting both sides. But those two are going to cancel. So same sort of thing as you cancel multiplying with dividing, you cancel adding with subtracting, you cancel squaring with square rooting, we're canceling tangenting with inverse tangenting. So then we want the inverse tangent of 0.15, which gives about 8.53-ish. Which may sound a bit small for an angle, but remember we definitely didn't draw this to scale because this 4,000 should really be quite a bit longer than our 600 here. So this should be an even tinier angle, so 8.53, yeah, that's about right, because you don't want to drop a plane at too steep of an angle. Or plain fish. Alright, so that's the big thing with that is just figuring out that, okay, this is the thing we're looking for from all these words. Lots of words. Which, again, is why I didn't want to do a whole section of that, so that's why this is part of 8.4 and then also 8.5. So there are a couple problems that are story problems, but most of them are the other stuff we were doing with just regular triangles. Alright, so that is pretty much that for trig, and next time we're going to be dealing with things that aren't right triangles. So far this has all been right triangles. I promise in the next section we'll get to things that aren't right triangles, because I know you're probably sick of right triangles. Alright, I will see you in the next one.